We are doing now a polarimetry experiment, polarimetry demo. So this is a polarimeter. It actually measures specific rotation or optical rotation of the sample. So there's a source of light. So there's a light in here. And then there's a sample holder. Once you put the sample, you are going to look through this eyepiece. So you will have a reading on the right and on the left. And then that gives you the degree of rotation of the sample, either going to the right or to the left. So this measures optical activity of the sample. If the sample is not optically active, or if the sample is optically inactive, you will not see any reading. If the sample is rotating light to the right, you're going to see a plus reading. If it's rotating light to the left, it's going to be minus. So if it's dextrorotatory, it's rotating light to the right. If it's levorotatory, it's rotating light to the left. And then we typically, we call it, we put a null value for the solvent. So this is basically just water. So this is the sample holder. So this is the sample that we're gonna put in this part here, okay? So as you can see, there's like water in here, okay? So there's like a bubble. So you have to avoid the bubbles. I'm just gonna fill it up with water. Okay? So that's gonna be, it's like you blanket with the solvent that you're using. So I'm gonna put it over here. So that's gonna be our blank. So if you look through this eyepiece, it's gonna go in. So you look through, and then you're gonna see what is called a it's like frames of view. And right now, when it's null, I don't see any color. It's like dark. And then if I move this dial here directly beneath that eyepiece, I will see either this left side or this right side, okay? But now it's gonna be this view looking through this eyepiece. Unfortunately, we cannot see through using the camera, but that's what you're gonna be, that's what I set it for right now, because I blanket. And if you see through this right side here, you can see that you can magnify this calibration. It's actually close to 0 right now, the setting over here, it's close to 0, but you can look through, and then it's magnifying this calibration. So this is a optically active compound. It's called L plus tartaric acid. So I weighed 5 grams of the sample in this 25 ml volumetric flask. And then the other sample is going to be the D isomer, which is going to be D minus tartaric acid. And I also weighed 5 grams of that sample. So I labeled that as D minus tartaric acid. And then the other one is going to be L plus tartaric acid. So I'm going to dilute this or dissolve this with 25 ml of RO water. Okay, and then that's going to be our sample. So this sample is L plus tartaric acid, actually this sample in here. So I can show you that in fact this is slightly off-white. Okay, it's not too white. So when I made the solution, it's actually not too clear. There's a slight tinge of coloration. And now the other sample is D minus tartaric acid, and this is the solution in water. So it's more transparent than the L plus. The D minus is more, has no coloration. So this sample is actually more white than the other isomer. So there's already a difference between the color of the solution, because one is slightly, very light yellow tinge to it. This one is completely clear. So I'm now using the tartaric acid as our first sample, the L+, and then I'm now going to put it here. So I'm introducing using this pipette. So I don't want bubbles. So I push the bubbles up. Okay, I got rid of the bubbles. Okay, so we are now going to just want to put it aside. Okay, so we're now going to introduce it into the sample holder, and then we'll see the reading. So once I put the sample inside here, it looks like the one on the left side, okay? So I have to, so when I look through the eyepiece, it looks like that figure with this, there's a line, and then there's a light. I have to rotate the bottom, so I will locate the null point. So after I rotated this dial, I located again the null point, which is the blank, when I look through the eyepiece, and now I'm gonna read this side here, and then it's gonna read as 2.4. So if you're now going to look into this eyepiece, and then you are going to look through this lens, you are actually magnifying this calibration. It's gonna read as 2.4. So what I'm seeing actually looks like this. So if this 0 is above the 0 on the right, it's a positive rotation. So that's what I'm seeing right now. So right now, the rotation or optical rotation of plus tartaric acid is 2.4 if you look through here. So it's like a calibration like this part here, positive rotation. Okay, so it's above the 0 mark. All right, so that's the reading for the tartaric acid positive, meaning that it's dextrorotatory. The next sample is the D- tartaric acid. So this is the isomer of L+. And we are now going to put the samples. I already put the sample inside. So this accommodates about 6 ml. So I had 25 ml from the volumetric flask. And then this is now the sample. So I'm going to put it now into the sample holder. Okay. So when I put it, if I look through the eyepiece, okay, I will actually see the image now, which is on the right side. So the previous example, I have the image when I put the sample, I have the image that I can see through. It's actually this image. So then I have to rotate the dial going clockwise so that I can have a null image when I see through the eyepiece. And then that's when I get the number, which is positive. When I put now the sample, which is D- tartaric acid, the image that I got when I look through the sample is actually this on the right side. Okay, so I have 3 images in here. This image, the null, and then this image. So this means that this is a little bit darker, and this is lighter. It's actually yellow, kind of yellow light, because the light is yellow. And then the one on the left side, this is lighter and this is dark. So what I'm seeing right now is this image. So now I have to rotate the dial here to the left, counterclockwise, so that I can get a null image, meaning I don't see a separation of the darker or lighter image when I see through the eyepiece. When I look through this magnifying lens, I can see the number over here. Okay, I can magnify it. And what I'm reading is actually now minus 2.4. So it's exactly opposite in sign than the previous example. However, the numerical value is the same. So it actually was now like this. So the reference point is a 0. So there's a dial going up and down. And previously I had it this way. So it actually is positive because this number is above the 0. So now it went the opposite way because the number on the left is now below the 0. So I'm reading it as minus 2.4. The previous example was positive 2.4 degrees. This example now is minus 2.4 degrees. The same amount of degree of rotation, except that one is positive, one is negative.